Good morning. I am Dr. M. Meenakshi from Department of Business Administration. Today we are going to see an important topic in statistics, that is correlation analysis. Now let me explain what is correlation. Correlation means the association between two or more variables. What we are trying to find out from the correlation analysis is we are trying to determine what is the degree of relationship between the variables. So, is there any relationship existing between two or more variables, and what is the degree? Based on that we can say whether the two variables are related or not. So in other words, we can also define the correlation as the correlation is an analysis of the covariation between two or more variables. Now let us see how we can classify the correlation. The correlation can be classified based on the direction of change of the variables, number of variables we are using for calculation, and rate of change between the variables. So based on the direction of change, we can classify the correlation into positive or negative. Based on the number of variables, we can classify into simple and multiple. Based on the rate of change between the variables, we can classify the correlation into linear and non-linear. Now, types of correlation. The first one is positive correlation. Let us look into the example. The positive correlation. X values 2, 3, 4, 5. Y values are 13, 12, 33 and 47. So, when you look at the values of X values are increasing, Y values are also increasing. That means the change is in the same direction. Here, when you look at these values, X values are decreasing, Y values are also decreasing. Here also the change is in the same direction. Then we can say that the correlation between these two variables are positive correlation. Now next let us see what is the negative correlation. Now look into the example. The X values are 2, 3, 4, 5. That is X values are increasing. Y value 8, 6, 4, 1. So one is increasing, the other one is decreasing. In that case, we can say that the direction of change is in the opposite direction. Therefore, it is a negative correlation. Here also, the X values are decreasing, Y values are increasing. That means the values are moving in the opposite direction. Therefore, the correlation is said to be negative. Then, we can look into the other categories. Simple correlation. What is simple correlation? When we are taking the relationship between only two variables, then it is said to be a simple correlation. When the relationship between more than two variables is studied, it is said to be multiple correlation. The other category is linear and non-linear. If the rate of change between the two variables is the same, the correlation is said to be linear. If not, it is said to be non-linear. Now, what are the various methods of studying the correlation? The first one is scatter diagram. Second one is graphical method. Third is concurrent deviation method. Fourth one is Correll-Pearson coefficient of correlation. Fifth one is rank correlation coefficient. And the last one is method of least squares. Out of the 6 methods, the Correll-Pearson coefficient of correlation, rank correlation coefficient and method of least squares are very important. Now, let us see how we can interpret the coefficient of correlation. The coefficient of correlation value lies between -1 to +1. So, if your value is exactly equal to +1, then you can say that the correlation is a perfect positive correlation. If the value is -1, then you can say that it is a perfect negative correlation. If the value is 0, then we can interpret that there is no correlation between the variables that we have taken it for study. Now let us look into one of the important method of studying the correlation, that is called Correll-Pearson coefficient of correlation. This Correll-Pearson coefficient of correlation is denoted by small r. We can calculate it using the formula r is equal to summation of x minus x bar into y minus y bar divided by n into standard deviation of x into standard deviation of y, where standard deviation of x is equal to root of x minus x bar the whole square divided by n. Standard deviation of y is equal to root of y minus y bar the whole square divided by n. And capital N is equal to number of pairs of observation. Now let us see one example. Calculate the Coral Pearson coefficient of correlation from the following data relating to the age of an employee and the number of days they were reported sick in a month. The data, age and number of sick days that their employees reported were given in the problem. So we have taken the age as X and sick days as Y. When you look into the formula, the values we have to calculate are x minus x bar, y minus y bar, x minus x bar into y minus y bar, x minus x bar the whole square, y minus y bar the whole square. So in the problem, they have given only the two values x and y. So now we have to find out the mean of x, that is x bar. Sum it up all the x values, that is sigma x. So our x bar is sigma x divided by n. N is 10 x values are there. So n is equal to 10. 460 divided by 10, that is equal to 46. Similarly, we can find out what is the y bar value, that is sigma y divided by n, that is equal to 40 divided by 10, that is equal to 4. Now based on this value, that is x bar is 46 and y bar is 4, we have to find out x minus x bar, that is x minus 46. Here we are finding out y minus 4. Then you multiply these two, x minus x bar into y minus y bar, we are getting these values. Then you square it, x minus x bar the whole square and y minus y bar the whole square. This x minus x bar the whole square and y minus y bar the whole square, these values are needed to find out the standard deviation of x and standard deviation of y. Now, we will see the solution. So, standard deviation of x is equal to root of x minus x bar the whole square divided by n. So, substitute the values, we are getting it as 10.44. Similarly, standard deviation of y, we are getting as 2.52. So, now the formula is r is equal to sigma x minus x bar into y minus y bar divided by n into sigma x into sigma y. Substitute all the values, we are getting the r value as 0.874. Now, how to interpret this? Since the r value is positive and the value is also on the higher end, we can interpret that there is a high positive correlation between the age of the employees and number of days reported as sick. This is how we have to calculate this Coral Pearson coefficient of correlation. Thank you.